Hey guys, welcome to today's video. So today we will solve one more question which is based on the algorithm called backtracking, and the question is rat maze problem. You may remember the maze game from the childhood. If not, I'll show you. So you might remember this game where the mouse wants to eat this candy and you are provided with the source and the destination, and you go through a series of hurdles like there are various paths to this candy, and you can reach with one of the path. This is called rat maze problem. So we are going to solve this. So let's replicate in the whiteboard. So if you consider this is a 5 cross 5 matrix where S is the source position where the mouse starts its journey, and F is the finish position, and the ones are the hurdles or the dead ends through which the rat cannot go. To solve this problem, we have a couple of constraints. So one of the constraint is, so mouse cannot go beyond the border of this game. So that is the one constraint. Second constraint is like the mouse can only move to the right or to the downward position. So it cannot go up and it cannot go in the reverse direction or to the left. These are the three constraints, and it cannot go through this blockers. Okay, and we need to find a solution, whether we need to find a path or the solution whether we have a path in this maze or not. So we are going to solve this using backtracking. So let's understand why we are choosing backtracking for this. So what backtracking exactly does, so as the name suggests, it checks for couple of options. So and whenever one of the option does not qualify for this, or if there is a dead end to that solution, or there cannot be any solution to that particular option, then we go backwards. So we go back to the previous position and we correct ourselves and go for the other options. So for example, suppose you started with this and you have suppose two solutions. One is first and the second, and we chose the first one and we went with this. Okay, and again with one we have two solutions. Okay, suppose 3 and 4, and suppose this has a finish. Okay, so and this is the dead end. So suppose we chose 3 and we came here, and this is a dead end. So what we will do, we will traverse back to this position, we correct ourselves, we are not going to choose this, and then we'll move to this to choose this. If this is also not the correct solution, then we'll go like to more previous solution. Okay, now from here we will change our direction from 1 to 2. So that is why it is called as backtracking. So whenever certain solution doesn't work, we go back and we change our solution. Okay, or we change our option and then we traverse in the same way. So to solve this question, we need couple of things. So first thing we need to consider, let's take a top-down approach to these type of questions. So whenever you get this type of question, don't just go into the details and start writing the code or anything. Just look at from the top view what all things you need to solve this, and then start writing the details of each problem. Okay, so if you want to subdivide this problem, what we need, which I can think of, is since we are at the source, first thing we need to consider whether which direction we need to go, and if we want to go in certain direction, how we will tell that this particular cell is a correct cell to go or not. So we need to check that whether our cell is correct or not, right? If we get the solution to that particular problem, that this cell is correct position or not, then we can go to the right and to the south direction from there. So suppose we come over here, so we are starting from here, so we can check this position is the correct position for us or not. If this is the correct position, then we can go this direction and we can go to this direction, right? So if we go to this direction, there is a dead end, right? So we need to traverse back. So at this place we can check whether this is a correct place or not. So if this is not the correct place, we will traverse back. So we need to keep track of certain things. One, whether the particular cell is the correct place to go or not. Second thing, whether we have already traversed or not. So these are the two most important things which we need to keep track of, right? And suppose to keep track that whether we have already traversed, we will mark the whenever we traverse that particular path, we will mark it as plus. Okay, we can mark it with anything. So let's consider over here plus. Suppose we mark it as plus, and then we came over here, there is a dead end, we went back. Now from here we left with only one option, okay, which is this one. So here we will check whether it is feasible or not. So this is a feasible one, right? So once we go here, we will mark this also as plus. Okay, now from here we have two options, to go this direction or to go this direction, right? So if you consider this direction, this is a dead end, so we need to go this direction. Okay, suppose if we change this maze a bit, okay, and we can just add one more dead end to it. Suppose what we do, we erase this and we add a dead end over here. Okay, we add a dead end over here. So in this condition, suppose we added a dead end over here, we add a dead end over here, and we add a dead end over here as well. So if you consider this, so these all are dead end and we were here, right? So we mark this as plus since we have traversed. Now we came here, this is also correct position, so we mark this as plus over here. Now from here we can go to this block or this block, but both are a dead end. Then what we will do, so what we need to do, we need to traverse back to our previous position. So while we are traversing back to the previous position, so this is not the correct, since this is not the correct path that we have traversed, so we need to erase this as well. So we would need to erase, sorry, I erased one as well. So we need to erase that we have traversed that position. Okay, so we need to erase that part. Okay, so it will be erased. So we will go over here. So here also we both the things we have already traversed. So this also we need to travel. So this also we need to erase. Okay, so we'll erase this. Okay, now since both have been erased, now we need to go to this direction. Since first we went to the downward, then we need to go this direction and we need to mark it as plus. Okay, since one of the options became incorrect, which we have traversed, so we need to erase this and we need to move to the other options. So this is the overview. So we need to solve first of all whether we can go to particular thing or not. Then we need to mark that particular place or the path we traversed as some marking, and then we will traverse back if the option is not correct, or we hit any blocker. Okay, so let's so so let's write the code for the same. So I have replicated the same maze in terms of 2D array. So the ones are the blocker and the zeros are the path which we can traverse. Okay, so let's write our method solve maze. By the way, let me tell you, for any backtracking question, these code will suffice. So you need to write similar code for all the backtracking approaches. So if you want to solve one question, you will find a similar question, like you can apply the same algorithm to other questions, chess problem, Sudoku. So you can solve all these questions with the backtracking algorithm. So all are similar. So we'll write a program called solve maze, and if it has a path, okay, then we'll just print out, yay, there is a path. Okay, or else we'll print there is no path. Okay, so we'll will pass the will so we'll create this method solve maze. So what we need to have, the initial position of the maze. Okay, let's consider it int I into j, then the maze itself. Okay, and for our ease, we will send the length and uh, the length of the array, the row and the column length. Okay, so we'll pass a starting position as 0 and 0, and then we are passing the maze and length of the maze, and this is the rows length and this is columns length. Okay, so we wrote, so these are what steps I'm going to write in English. This is applicable for all the backtracking based questions. So first we will find the terminating conditions. Okay, so like I told you, there is a constraint that it cannot go beyond the border of this, so these can be treated as the terminating condition. Okay, check if we finished, or if we finished or we got the solution. Okay, so we'll check if we have already finished or got the solution or not. Okay, then we'll check if current position is blocked or not. Okay, if it is blocked or not. Okay, if it is not blocked, then we'll mark it as traversed. Okay, we'll check down and right direction. Okay, if we got the solution, then we'll return true. Else unmark the position and return false. So these are the steps. So these steps is applicable for all the backtracking question. Okay, so let's write the terminating condition. So we'll check if our I is greater than or equal to n, or j is greater than equal to m, or I is less than 0, or j is less than 0. If any of the condition is true, then we are returning false. So the solution doesn't exist. Okay. Now we'll check if we have finished or not. So since we know that this is the end one, so and since we haven't marked it as a finished line, so we can just check if our I is equal to n minus 1 and j is equal to m minus 1. This means we have reached our solutions. We'll return as true. Okay. Now if we haven't reached our position, so we'll check if we have already traversed this solution. How we will check? We will check maze of I of j is equal to 2. So we can take any so you can use hash or plus sign, anything. So since we have an integer array, so we are using 2 as the identifier that it has been already marked. Okay. Now if we have already traversed, or maze of I j is equal to 1, or it already has a blocker, so we can simply return false for this, that we cannot traverse beyond this. Okay. Now if we are going forward to this, we need to mark this path as already traversed. So what we can do, maze of I and j equal to 2. So we have marked this as that traverse. Now since we can only go downward in the right direction, so we'll check if solve maze of I plus 1 and j, maze and m remains the same. If we got the solution going to the right direction, so how we can go to the right direction? By doing I plus 1. So if we increment the rows, now the rows ID, then we can traverse to the right. So if we get the solution there, or we get the solution to the downward in, okay, then we can return true. Okay. If we did not get return true from here, then we would need to backtrack. And how we do the backtrack? With only one line. So we can just do I j is equal to 0. So why we are marking it as 0 and not 1? Because there was a path, but since we cannot traverse it, so we are replacing back as however it was in the previous case. So previous case it was 0, so we are marking it as 0. Okay, and we can return false. So this is it. These are the 1 2 3 4 5 6 7 lines of code for any backtracking question. So based on where you can traverse, this will change. So as part of this, you can mark it as down and rightward direction. So we use these three. If we are able to traverse all the 4 directions, then we'll have this 4 conditions: up, down, left, right. Okay. Now these are the constraints which will change according to the question, like whether how we are marking it as a blocker, and if something is blocked or not. Okay, this condition will also change. If we are considering 0 0 as a finished position, then we'll check for the 0 0. Okay, and these are the terminating condition or the end conditions, which will like for any matrix this will suffice. Okay, it might change based on the question as well, but this is how the structure of a backtracking solution looks like. Okay, let's run this whether we have a solution or not. So yeah, there is a path. So there is a path from here. Okay, suppose I changed this and I blocked the path, so there is no path to this. So from wherever you come, you can never reach to this destination. Okay, let's test it out. So there is no path. Okay, suppose I made it 0 and this as 0 and this as 0 and this as 1. So still it should not be able to create any path, which is true. And if I make it as 0, then it can kind of come over here, so it can traverse from here to here, so there should be a path. Yeah. Okay, so try solving other questions like Sudoku and chess problem and let me know if you're able to do it. See you in the next video. Thank you.